Okay, in this video I want to show you how you can use the llama files, the local models, and n8n to generate data models. So I have created this simple workflow that records audio. So it first records audio from the microphone and then it transcribes this audio. It prepares the input, then it plays some sound. Then it asks the llama to generate the MERMA ID, which is it's a language to define class diagrams and flow charts and other things, but also the SQL schema to generate the tables. Then it basically extracts those pieces of code, both the MERMA ID and the SQL, and it generates an HTML template, which turns into a base64, and then it saves it into a file. So basically it saves in an HTML the MERMA ID code and the SQL code. So let's try it and see how it works. There are products and orders. An order has a payment, and a payment has an invoice that belongs to the order. Okay, now it's recorded, it's transcribing this audio.
I am proposing a data model based on these requirements. There are products and orders. An order has a payment and a payment has an invoice that belongs to the order.
Now it's calling the local llama file. So it's running, everything is running locally, both the transcribe, the record, and the audio play, and the generation itself. It's generating both pieces of code, MERMA ID and SQL. Takes some time. It's the 70 billion, the one that is running, the llama 70 billion. Okay, it's done. So it saved a file here. You see in the desktop, it saved this file. Let's open it. And I see that it generated correctly the MERMA ID and the SQL migration. Let's copy this and let's go to the online MERMA ID editor and paste it. Let's see. Okay, there is a syntax error here. I think these double quotes are not... it made a mistake there, but you can correct that in the prompt. I think I mentioned something in the prompt, but as you can see, here is the model. Well, it didn't write the relations, so let's fix that. Let's say here, this is the system prompt. So I'm going to say include the relationships between the tables. I'm going to say make sure the SQL has indexes when needed. Okay, so this is going to be the system prompt. Let's try it again. There are products and there are orders. An order has an invoice and the invoice has a payment.
I am proposing a data model based on these requirements. There are products and there are orders. An order has an invoice and the invoice has a...
Okay, it cut the last part, but yeah, it's just a test. Take some time. Now it's writing the relationships and the indexes apparently. Let's see, I reload this and I don't know what it did here. Let's see. Okay, so it has the relationships, but it doesn't have the fields. It doesn't have the fields, so you have to update the prompt so that it makes sure that it proposes fields as well. It made a simplified model, but it included the SQL schema with the indexes and the relationships. So yeah, it saves some time. Let's see how this works first. I'm using the rec command to record, and I'm using this command to record until there are 3 seconds of silence. So it starts recording and it saves the recording in this WAP file in this folder. And once it detects 3 seconds of silence, then it stops. So the node moves forward, and the next command is the transcribe. I'm using Whisper. So Whisper is a software to do transcriptions also in C++, so it's quite fast. And there are llama files as well. So it's a local file, a local binary that basically reads from this WAP, and it outputs this basically, like the initial time and end time and the text that it found. So because I don't need this first part, right, what I do is I run the prepare. So I go through all the items in stdout and I remove the new lines, and I remove the initial part, like the time code. I strip the time code so that I end up with the text only, and then I join all the blocks with spaces so that it all is in a single block. Okay, so here I have the output. So the prepare has the full output, and this one sets the system prompt. I just put it separated so I can edit it easier. So this is what asks the model what to generate and a sample output, right? So this is the system prompt, and the prompt itself, I have it here. So this is the request to the local llama file, and here I basically you see that it constructs the prompt using the transcription. So using the prepare JSON items here, the one that was transcribed from the audio, it puts it here. So this is the prompt, and the system prompt should be somewhere there. Yeah, in Llamafile, in this way I found, I'm not 100% sure, but they mentioned that you have to specify the system prompt in this way, so inside the prompt with this syntax, but I still have to check that out. It's for the Llamafile, the local Llamafile. Basically this will return something, so it will return some explanation but some code, and in this code block I basically extract both the MERMID and the SQL so that I end up with 2 columns, right? In the next node I basically turn those 2 columns into an HTML template here. Basically I convert this HTML to base64 to binary, and then I convert this binary to file and I save it. And this is the file that you see here on the right. So this is a simple example how you can use local llama files for your software development activities. This is like a simple approach, but it can be extended so that it collects feedback. Like it has some stage where it gathers the feedback about the data model, and then it confirms, and when you confirm it, then it goes to the generation mode. So it can definitely be extended. I think it's quite useful, and I hope you guys like it. Let me know in the comments what you think. Bye.